Hey class, we're going to continue with 10.3, and now we're going to use the p-values as rejection rules. So I'm going to go back to my PowerPoint. Okay. Alright, so here we go. Alright, so these p-value rules have not changed from 10.2. So if the p-value is less than or equal to that alpha, then you reject your null. But if your p-value is greater than your alpha, you fail to reject the null. So let's look at this. A locally owned independent department store has chosen its market strategies for many years under the assumption that the mean amount spent by each shopper in the store is no more than $100. A newly hired manager claims that the current mean is higher and wants to change the marketing scheme accordingly. A group of 27 shoppers is chosen at random and found to spend a mean of $104.93 with a standard deviation of $9.07. Assume that this population is normally distributed, that the population distribution of amounts spent is approximately normal, and the test the managers claim at 0.05 level of significance. Alright, so we got to design our hypothesis. So the store manager claims that the mean is more than $100. So we can mathematically write that as the mean is greater than 100. So that's going to be our alternative, which means our null is the mathematical opposite, so the mean is less than or greater than $100. Now we're going to determine which distribution to use for the test statistic and state the level of significance. A student's t distribution, and therefore the t-test statistic for population means, is appropriate to use in this case because the claims about the population mean is normally distributed and the population standard deviation is unknown. The sample is extemporaneous random sample. The level of significance stated in this problem, the alpha equals 0.05. Gather the data and calculate the necessary sample statistics. Alright, so let's use this in the calculator. So we're going to write down our information for the problem. We're going to have our population mean is 100, our sample mean, x bar is 104.93, and our sample standard deviation is 9.07, and the sample size is 27. So press stat, then do test, and choose option 2, t-test. All right, I'm going to do this with you while you do it. Stat, test, 2, which is t-test. Okay. So we're going to input the statistics because we know everything from them. Okay. For the null mean, we're going to enter the value of the null hypothesis, which is 100. Then we're going to, just a second. Then we're going to enter x bar. So x bar, hold on. X bar is going to be 104.93, and then we're going to do this sample standard deviation, which is 9.07, and it's 27, and then we're going to pick which one we want. Remember, this has to be our alternative. So greater than is going to be our choice. So remember, go over to that, click on it, and then hit enter. And then you're going to hit calculate. And then, let's see what you get. Hit enter again. Did you get this? That the mean is greater than 100. T equals 2.82, which that's your t-test statistic. And then P is 0.00448. And then x bar, and it gives you the rest of your stuff. All right, so let's look at that p-value. That p-value is 0.004. Since 0.0045 is less than 0.05, we have a p-value that's less than or equal to alpha, so we reject the null. So that means there's evidence to support the manager's claim that the mean amount spent by each shopper in the department store is more than $100. Okay, let's do one more. The mean packing department of a large grocery store packages ground beef in 2-pound portions. Supervisors are concerned that their machine is no longer packaging the beef to the required specifications. To test the claim that the mean weight of the ground beef portions is not 2 pounds, the supervisor calculate the mean weight for a random sample of 20 packages. The sample mean is 2.10 packages with a standard deviation is 0.33. Is there significant evidence at the 0.01 level of significance to show that the machine is not working properly? We're assuming everything is normally distributed. So we got to state our null and alternative hypothesis. For this one, it's kind of easy. It doesn't want to know if it's less than or greater than. It just wants to know that it's not equal to. So the mean isn't equal to 2, where your null hypothesis is the mean is equal to 2. So we're going to write everything down again, and we're just going to put it in our calculator. So we're going to do another t-test. We're going to do statistics. Our mean is 2. Our sample mean is 2.1. Our sample standard deviation is 0.33. Our n is 20. And then our alternative mean is not equal to the mean. So when we run the statistics, we look at that p-value. That p-value is 0.1912. So since 0.1912 is greater than 0.01, we fail to reject the null. And that means the evidence collected is not strong enough at the 0.1 level of significance to show that to say that the machine is working improperly. So we have to assume, I guess, it is working properly. So, all right, well, I hope this helped, and let me know if you have any questions with 10.3. Thanks.